question is find y parameters for the given network. So y parameter means we know the definition is I1 is equal to y11 v1 plus y12 v2 and I2 equal to y21 v1 plus y22 v2. So we need to analyze the circuit and obtain an equation for y1 in terms of v1 and v2. Similarly, we need to write I2 in terms of v1 and v2. So for that we can take node equations. Now what is I1 in terms of v1 and v3? I1 can be written as v1 minus v3. Okay. Now here v3 is not allowed, right? So let's write this node equation with respect to v3. When we write the KCL equation, with respect to this, I1 is given as entering, so let's keep it as such. I1 is equal to V3 by 1 by S, which is S into V3 plus V3 minus V2 by 1, or this is S plus 1 into V3 minus V2. But we know that I1 is V1 minus V3, correct? So let's substitute it here. So we'll get V1 minus V3 is equal to S plus 1 into V3 minus V2. Okay. So from there we can write V3 is equal to V1 plus V2 by S plus 2. So this is equation 1, this is equation 2, and let this be equation 3. So we can substitute for V3 in equation 2. So substitute 3 in 2. We'll get in 2. So I1 is equal to S plus 1 into V1 plus V2 by S plus 2 minus V2. Now on simplification, we'll get this as, this is equal to, we'll get it as S plus 1 by S plus 2 into V1 minus 1 by S plus 2 V2. Now this is in the standard form. Okay. We can compare this with, now we can compare this equation with the standard describing equation, and on comparison we will get that y11 is equal to S plus 1 by S plus 2 and y12 will be minus 1 by S plus 2. Now similarly we can write equation for node 2. For node V2, if you write it for node V2, the equation will be I2 is entering, this is equal to V2 by 1 by S, that is S into V2 plus V2 minus V3. Now we can substitute for V3. This is equation say 4. Put 3 in 4. We'll get I2 is equal to SV2 plus V2 minus V1 plus V2 by S plus 2. Now this if we rearrange it, we will get it as minus 1 by s plus 2 v1 plus s square plus 3s plus 1 by s plus 2 v2. This is I2. Thus we got I2 also in terms of V1 and V2. Comparing with the standard equation, this is Y21 and this is Y22. Thus we can write matrix Y equal to 1 by S plus 2 into S plus 1 minus 1 minus 1 and S square plus 3S plus 1. Next question. Determine short circuit admittance parameter for the given network. So here again we need to find the Y parameters. So we need to write the current equations in terms of voltages. So let this node value be V3. Now node 1 we can write. Node 1 will be, this is V1, this is V2. Okay, so node 1 will be I1 is equal to V1 minus V2 by 1 by S, that is this into S, plus V1 minus V3 by 1, or this is equal to S plus 1 into V1 minus SV2 minus V3. This is I1. Here there is V1 and V2, but we have to replace this V3 also. So let's mark this as 1. Then we can write equation for node 2. That will be I2 is equal to V2 minus V3 by 1 plus V2 minus V1 by 1 by S, or this will be minus SV1 plus S plus 1 V2 minus V3. Again there is a V3 term. Now node 3. With respect to V3, we can write as V3 by 1 by S, that is S into V3 plus V3 minus V1 plus V3 minus V2 equal to 0. Or from there we can write V3 is equal to 1 by S plus 2 into V1, or V1 by S plus 2 plus V2 by S plus 2. This is equation number 3. Now we can substitute 3 in 1 and 3 in 2. So when we substitute 3 in 1, we will get, after simplification, we will get I1 is equal to S square plus 3S plus 1 by S plus 2 into V1 minus S square plus 2S plus 1 by S plus 2 into V2. This is in standard form. So this is Y11 and this is Y12. Same way we can put equation number 3 in equation number 2, and on rearranging we will get I2 as minus S square plus 2S plus 1 by S plus 2 into V1 plus S square plus 3S plus 1 by S plus 2 into V2. So we have got all the 4 parameters which can be written in matrix form as So this is how we solve the equation. So when you are asked to find out y parameter, try to express the given circuit in current equation by applying node analysis. Next question, find y parameters for the circuit shown. So here the circuit contains a dependent source. Let's write node equation for node 1. It will be I1 is equal to V1 by 4 plus V1 minus 8V1 minus V2 by 2. Now this voltage is V1 and this voltage is V2. Or this on simplification we will get I1 is equal to minus 13 by 4 V1 minus 1 by 2 V2. This is in standard form. I1 expressed as V1 and V2. So Y11 is minus 13 by 4 and Y12 is minus 1 by 2. Now we can write node 2. That will be I2 is equal to V2 by 4 plus V2 plus 8V1 minus V1 by 2. Okay. And this on simplification we will get 7 by 2 V1 plus 3 by 4 V2. Again this is in standard format. So nothing much to do. Just write the KCL equations. You will directly get the answer in terms of V1 and V2. Now we can write it in matrix form. Matrix Y is equal to minus 13 by 4, minus 1 by 2, 7 by 2 and 3 by 4. Parameters for the circuit shown. So here again we will write the node equations. So let's write the first node, node 1. Node 1 will be I1 is equal to V1 by 2 plus V1 minus V3 by 1. Or this is equal to 3 by 2 V1 minus V3. So here we need to remove this V3 and express it in terms of V1 and V2. So let this be equation number 1. Next is node 2. I2 is equal to V2 by 1 plus V2 minus V3 by 2. Or this will be equal to 3 by 2 V2 minus V3 by 2. This is equation number 2. Now we can apply node analysis on 3. That is, there is nothing entering, so 0 equal to 4V1 plus V3 minus V2 by 2 plus V3 minus V1 by 1. Or we will get V3 equal to minus 2V1 plus V2 by 3. Now that 3 can be substituted in equation 1 and equation 2. So we can substitute equation 3 in equation 1. We will get I1 is equal to by 2 V1 plus 2 V1 minus V2 by 3, or we'll get this as 7 by 2 V1 minus 1 by 3 V2. This is our standard equation. We got I1 in terms of V1 and V2. Similarly, we can substitute 3 in 2. we'll get I2 is equal to 3 by 2 V2 plus V1 minus V2 by 6, or this is equal to V1 plus 4 by 3 V2. Thus I2 also we got in terms of V1 and V2. We can write the matrix Y matrix. Matrix Y is equal to Y11 is 7 by 2 minus 1 by 3, 1 and 4 by 3. This is Y matrix.